Hey everyone, my name is William and I'm a teaching assistant for the Microcontroller and Embedded Systems lab. And today I will be talking about how to get started with your Red Pitaya and how to kind of work within the file system so you can get your code running and complete the first lab. So I'll be starting off with the Red Pitaya, and it is connected to a wall outlet with the black cable and the Ethernet port on my computer or dongle with the red cable. And something I've noticed TAing this course for the past 3 semesters is that if there's typically a problem, it's that the micro SD card slot, the SD card within it is not, fully within the slot. So if you ever have a problem connecting to it, maybe try, reinserting the SD card or just reattaching your cables. So also is that you should see a green LED indicator light going off, and if it's like a stable color, that means you're all good. And typically I wait about 15 to 30 seconds after connecting the Ethernet cable between my computer and the Red Pitaya before I try to connect to the device. So it takes some time for the Ethernet cable to get set up, but once it is, you should be good to connect. So now let me go ahead and connect to my Red Pitaya. In order to do that, we will use SSH, and the command is SSH space root at, and then the address of my Red Pitaya. So the address you could find is either on your aluminum case on a sticker or on the kind of board itself, but they also ship it with this kind of sticker. And the sticker may be attached or just within your kit, but type out that address. So rp-f0af05.local. That is the address of my device, but yours will be different. Now, if this is your first time connecting your computer to this device, you will need to type in the word yes or no. So type in yes in that case, and then that just kind of allows your computer to connect to the device and add it to the list of devices it kind of knows about. Now, when we type in the password, the text box will not update, kind of like if you're writing a document in Microsoft Word where the text will kind of update as you type it out. In this case, it will not update, and I don't know the exact reason. Maybe it's for security reasons when you type out a password, but that's just how it is. So the password in our case for our devices is root, R-O-O-T. So type that out, then press enter. And now we know that we're within our Red Pitaya because on the left, we have the device root at rp- our address. And now we could see we're currently in the like home directory. And to confirm that, we could type the command pwd, which is the path of our working directory. Now, as we complete labs throughout the semester, I recommend setting up different file systems for each lab. So, for example, for lab 1, I'll have a file directory called lab 1, and for our last lab, lab 9, I'll have a file directory for lab 9. In order to do that, we could type out the command mkdir space directory name. So in this case, mkdir space lab 1. Now, in order to see what directories are accessible from our current position within our file system, you could type the command ls. We could see there are 2 directories available called in lecture code and lab 1. Now, let's say later on we want to work on lab 2. I'll go ahead and make the directory called mkdir space lab 2. Let me list the directories again with ls, and we could see that now we have lab 2 available. So we want to split up our code between each lab because we'll be working with build files and make files and even reusing some code, and we do not want to get the code mixed up with each other. So that's why I recommend putting them in different file directories. So let's go ahead and access lab 1 and create the code for lab 1. So in order to do that, we want to change into that directory with the command cd. So cd space directory name, in this case cd space lab1. Press enter, and now we're within lab1, and we could see that it is currently empty with the ls command. In order to type out files, we can either do two methods, which I'll present in this video. First, we could type it out on our Red Pitaya through the VI editor, or we could also type out our code locally on our computer and then kind of copy that code file over to the Red Pitaya with a terminal command. So in this case, I will, for the lab1, I will just write it locally on our Red Pitaya with VI. So we could do the command VI space hello world.s. Using this command, it automatically puts us into the hello world.s file, and we can see that in the bottom left-hand corner. And in order to type out the code, we need to enter insert mode. In order to do that, you press I on your keyboard. And we can see that in the bottom left-hand corner, we're now in insert mode. So now I could type in things such as hello world. And in order to exit insert mode, we press escape. Now, in order to kind of navigate, say you have a bunch of code, so let me type lab1, lab2, lab3. This is just a visual example. So say you have multiple lines, what I see students do is they use their arrow keys to navigate between these different lines. However, you could also use the J. So once you get out of insert mode into normal mode by pressing escape, you could use J and K to navigate up and down, and H and L on your keyboard to navigate left and right. However, most students I see use the arrow keys because that just seems the most intuitive. Now, let me put the code for hello world.s into this file. And this code is, the code for your labs will typically be found in the textbook or in the lab assignment. So I already have the code for hello world.s written out. So let me just go ahead, copy and paste it. And there are typically problems when you copy and paste code from the textbook. So we really recommend writing it out line by line, and it's just good practice so you can learn how to do the assignment, and so you can learn assembly code. And oftentimes, most errors I'll see is because when you copy something from the textbook and type it out, there's typically just maybe one symbol or one letter that a student forgets to kind of type out, and that causes a lot of errors. So now that we have hello world.s, and the file looks good to me. So say we're in insert mode with the bottom left-hand corner saying insert. To exit this, you press escape. And to save the file, you type :WQ. So that writes and quits the VI editor. So now, let me type ls, and we can see there's hello world.s. So let me open it up again. And we can see that the code we just wrote out saved. And in order to quit the file without saving, you could do escape, Q, exclamation point. And that will quit our editor without saving the file. So next for lab 1, we're going to be working with build files. Another way you could create a file is with the touch command. So touch space build. If I type ls again, we could see that build shows up in our file directory. However, it is going to be empty. So let's go ahead and edit the build file. So vi space build. Now I already have the code written out for build. It's this code. So let me enter insert mode by pressing I on the keyboard, and then just paste the code. And let me save this file with the command escape, :WQ. Another way I could confirm the code within a file is type in the command cat. So cat space file name. So cat space build shows me that the 2 lines I just pasted over into the file are saved into build. Now for lab 1, we want to use build to assemble our hello world.s file. In order to do that, first we need to make build an executable with the command chmod space +x space build. So that changes the mode of build to be an executable with the +x, and +x stands for executable. So now when we type ls, we'll see build is green, which means we could run build and that will kind of assemble our code. So /build will run build, and we could see that there's currently an error on hello world.s line 1. So this is good because this will happen a lot. You'll get kind of these messages that tell you, hey, your code is not working on this line number, so go to the line number and fix it. So we could see in hello world.s line 1, we have a bad instruction, assembler program, to print hello world. Now, from my experience, I know that means that I forgot to put an @ symbol, which is a comment on the assembly language. So let me open hello world.s with vi, and I could see line 1, this top line right here, there's no @ symbol, which means that the compiler thought that this was some sort of instruction to run, when in reality it should be a comment. So let me enter insert mode with I and put an @ symbol and save this file. Okay, now let me rerun build. Now something that I do is I use the up and down arrow key on my keyboard to run previous commands. So because I know I ran /build prior to this, I use the up arrow and I could get to it without having to type it out again. So let me run that again. And we could see this time there is no assembler message. And that means that our code ran and there should not be any errors. So now let me type ls again. Now we could see that the build file created a kind of this program we could run called hello world that is highlighted green. So in order to run that, you do / and then the name, hello world. And it prints out hello will be Orndal. So the output works as expected. So this kind of shows you that we could use the Red Pitaya and write our code on that device and build and run it pretty seamlessly. Next, I'll be showing you how to write your code on your local computer, and then you could copy that file over to the Red Pitaya, and that way, some people prefer to use a visual text editor in that case. So I'll show that right now. So let me go back to the home directory, and in this case, I will just move back a directory with the command cd space .. So now if I type ls, I could see that I'm back at the kind of root where we have the in-lecture code, lab 1 and lab 2. So if I type ls lab 1, I can see all the files that are within lab 1. And these were the files we just kind of were working with. Now if I type ls lab 2, we could see that there's no files in there. And the next kind of set of files I'll be putting within lab 2. So I use Visual Studio Code on my local computer, and within that, I created these files, which we'll be using in the first part of lab 2, called makefile and hello world.s. So the hello world is pretty much the same file, except we're going to, instead of building it, we're going to use a makefile. So let me show you that we rename this to lab 2. So if you're within your documents on your local computer, you can kind of do a similar setup to where, okay, I have my lab 2 documents in this file directory. So in this case, I have hello world.s and makefile. And when I open them using any text editor I want, in this case, I'm using Visual Studio Code. Let me show you. Okay, So here they are within the text editor. So people like to use the text editor because maybe you get syntax highlighting and it's just easier to kind of see the code and interact with it without having to remember those commands for the VI text editor. So once we have makefile written out and saved and hello world.s written out and saved on our local machine, we need to open up a new terminal. And then within that, let's change into the directory with our files. So in that case, I was within my documents and lab2 file directory. So cd space documents space lab2, or sorry, tab lab2. So when you're in the terminal, you can kind of auto-complete the word you're writing with the tab command. So again, this is on my local system. You can see I'm on my MacBook. And we have hello world.s and makefile. So what I'm going to do is transfer these files over to the Red Pitaya. First, I'm going to transfer makefile to the home directory, and then show you how you can move the file from your Red Pitaya home directory to a new file directory within it. And then I'll transfer hello world.s directly to lab2 directory on my Red Pitaya. So in this case, we're going to use the command scp. And this will work on Windows Terminal, Mac Terminal, any Linux distribution, and so we do scp space the file name that we want to transfer. So in this case, makefile space, and then the device that's connected to our computer. So because our Red Pitaya is connected via Ethernet, we'll type the address, so rp-f0af05.local. And then next, without any spaces, we want to do colon and then dot. And then the colon dot will place the file within our home directory of the Red Pitaya. And it'll ask for the password. Password is root. And we can see that the file transferred over. So let me go back to the Red Pitaya terminal and type ls. We can now see we have the makefile. In order to move the makefile to our lab2 directory within the Red Pitaya, we could do the command mv. So mv space file name, makefile, space desired directory we want to move into, so lab2. So if we list the kind of files, we'll see that it is not within the home directory anymore, and we can see that makefile is within lab2. Now back on our local machine, we could see we copied the makefile over, so we don't lose it on our local machine. It just got copied over. So now let's copy over hello world.s, but put it directly within the lab2 file on our Red Pitaya. So I'm going to use the up arrow key to get my previously run command, and I'm going to change makefile for hello world.s. And then instead of the colon dot, I'm going to do colon dot slash lab2. So we're showing that we're kind of starting at the home directory on our Red Pitaya and then going into lab2 because lab2 is accessible from home. So enter, type out the password, and now let's type ls again within lab2, and we'll see hello world.s. Great, so now we have the files over into the desired directory on our Red Pitaya. Now let's go ahead and make our file. In order to do that, throughout the semester, I recommend just using this command every time, make space -b space debug equals 1 in all caps. And this allows us to debug our file, which will be useful for pretty much most labs of the semester. So when we run this command, we'll see that we got one assembler message and it says end of file, not at end of a line. And this is more of a warning, so it didn't stop our code from compiling. It's just showing in this case that we have an extra line, and like an empty line at the end of our file, but it's not going to break our code. So when I type ls again, we can see that we have hello world in green, which means we could run it with the /hello world. And it says hello world, or hello will be run all makefile, because we used a makefile. And I wrote that in the hello world.s file. So this is just showing that we could use different ways to make our files, whether it's build or make, but for most of the semester we'll be using makefile. And I can't recommend enough always running this make space -B space debug equals 1 for our assembly code, because that will just enable all the settings we need for debugging our code. And I noticed there's a lot of errors when students do not include the debug equals 1. It will interfere with completing the lab assignment. So be sure to do that, to include those kind of flags. One more thing I would like to say before ending this video is that say we are within lab 2, but we need to kind of make a different file. I really recommend putting a make file, like a new make file in a new directory. So say we're on lab 2 and all of this code is for part 1 of the lab. Now let's say part 5 of the lab assignment wants you to make a new file and make a new make file. Well, then what I would recommend doing is do the command mkdir space like part 5, for example, and then cd into part 5. And then from there, you could make a new make file and add whatever code you need that corresponds to that make file, because there will be errors if you try to kind of have multiple make files within the same file directory. So that's just something to be aware of.